Hello guys, welcome back to a new video. In this video we'll be solving section review 4.2. Okay, we have a jeweler working with a heated 47 gram gold ring, which have to lower the ring's temperature to make it safe to handle. So first of all, as usual, we have two givens. We have gold and we have water. Mass of the gold is equal to 47 gram. Make sure to change it to kilograms. It's going to be 47 times 10 to the power minus 3 kilogram. Okay. Now, if the ring's initial temperature is 99, if the ring is initially at 99 Celsius, so T initial is going to be what? 99 Celsius. Okay. What mass of water at 25 Celsius is needed to lower the ring's temperature to 38? So we don't have the mass of the water, which is equal to we don't know it. Okay, now the T initial for water is equal to 25 Celsius. Okay, it says what mass of water at 25 Celsius needed to lower the ring's temperature to 38? Do you have T final for both of them? Yes. Since the ring is going to be put inside the water, so T final for both is going to be 38 Celsius and T final for water is going to be 38 Celsius. Cp of gold is equal to 129 and Cp of water 4186. Okay, Q lost by the ring is equal to Q gained by the gold, by the water. So this is ring, which is gold, and this is water. Heat lost by the ring equals heat gained by the water. Cp of gold times mass of gold times change in the temperature of gold is equal to Cp of water times mass times change in the temperature of water. Now, delta T for the ring is going to be T initial minus T final. Careful. Why is that? Because the ring is going to lose heat. Whenever a substance loses heat, delta T is going to be T initial minus T final. For this one, because it has gained water, so it's going to be T final minus T initial. Okay, let's continue. We are trying to find mass of the water. Okay, not to confuse them, you can write CpG, mg, change in temperature of G. This is water, and this is water. Now, Cp of gold is equal to 129 times mass, which is equal to 47 times 10 to the power of minus 3. This is equal to what? Times 99 minus 38 is equal to 4186 times, do we know mass? No. So mass times T final minus T initial, this is going to be 38 minus 25. Okay, now multiply the numbers. Okay, you get 369.843 from this side. For the other side, you get 54,518 m. Don't forget the m. Okay, this is basically 13 multiplied by this one, and you get this one. Okay, now divide this by 54,418. Divide the same number, 54,418, cancels. Mass of the water is equal to what? It is equal to 6.79 times 10 to the power minus 3 kilogram. This is the mass of the water at 38 Celsius. Using the latent heat concept of heat and internal energy, explain why is it difficult to build a fire with damp wood, basically woods that are wet. Okay, why is it difficult? First of all, we're going to need a lot of energy to dry the water. That's the first thing. Okay, and then we're going to need more energy to make the wood catch fire. Okay, so it's basically going to be really difficult. Okay, and since the the wood, and the wood is damp, okay, so it's going to have a lot of potential energy, okay, so overcoming that potential energy is really difficult and it needs a lot of energy, okay, that's why building a fire with damp wood is difficult, okay. Why does we have question 3, why does steam at 100 Celsius causes more severe burns than water at 100 Celsius? Now, if you remember, I'll try to relate this to latent heat. If you remember, we said that in order to change solid, for example, ice to liquid, we needed something which was called latent heat of fusion, okay? So this is also related to this one. Water and steam, they both can exist at the same temperature, but steam has more energy, okay? And the energy is used to break down the bonds of the water. This is basically the energy that you have given. So that is why steam has more potential energy, okay? It has more energy, which is basically the energy we gave it to overcome the bonds between the water molecules. So you can answer the question by just saying that because steam has more potential energy, and that is why it causes more severe burns. And when your hand is exposed or your skin is exposed to steam, this potential energy, which is really high in steam, is going to be releasing the energy as heat. That is why it's going to cause more burns, okay? We have question 4. Question 4, you'll see this a lot, questions like this in this chapter, so pay a good attention to them. We have the following curve from the heating curve for a 15-gram sample as shown in the figure below. Estimate the following properties of the substance. First of all, we have mass, which is equal to 15 gram. Change it to kilograms. It's going to be 15 times 10 to the power of minus 3 kilogram. Now, something really important is this, that this is given in kilojoule. Kilo basically means 10 to the power of 3. So this is going to be 1.27 times 10 to the power of 3. Here we have what? From this side, we have temperature from 0 Celsius to 400 Celsius. From here, from the horizontal side, from the X, we have 0 joule to 796 joules, kilojoules, sorry. This is given in kilojoules, which means when you are solving questions, you should always multiply them by 10 to the power of 3. Question, the first question A, it says the specific heat capacity of the liquid. So, where is the liquid? We are trying to find the specific heat capacity curve for liquid. This is the liquid, guys, okay? This is the liquid part, okay? It is from where? First of all, it is from, always subtract the bigger one from the smaller one, careful. 15.8 kilojoule, and we have 8.38 kilojoule. From what temperature? From 100 temperature to 300 temperature, okay? So A, it needs what? A, it needs the specific heat capacity of the liquid. So first of all, specific heat capacity is equal to what? It is equal to Q divided by mass divided by delta T. Do I have Q? Okay, how can I find Q? Q is going to be what, guys? It is going to be this one subtracted by this one, okay? So for finding Q, I'm going to say Q is going to be 15.8 subtracted by what? Subtracted by 8.37, okay? you get what? You get 7.443, okay, kilojoule. Change this to joule. This is going to be 7,430 joules. Okay, now let's just plug in the numbers that we have. CP is going to be 7,430 joule divided by mass is equal to what? 15 times 10 to the power of minus 3 times delta T is going to be what, guys? It is going to be 300 by subtracted by 100, okay? So 300 subtracted by 100. Calculate this and you get CP, which is equal to 2.476 times 10 to the power of 3, okay? This is what this is joule, okay? We have question B. It says the latent heat of fusion, okay? It says the latent heat of fusion, okay? What do you mean by latent heat of fusion? First of all, we should subtract we should know the equation for latent heat of fusion. So for latent heat of fusion, we have latent heat of fusion, Q is equal to MLF, and we are trying to find what here? We are trying to find latent heat of fusion. So this one divided by M and this one divided by M. So latent heat of fusion is going to be Q divided by mass. Now, how do I find this one? Where do I get this number from? It's asking for latent heat of fusion. And what is latent heat of fusion? It is basically solid to liquid or liquid to solid. And the temperature is what? The temperature should be constant. Careful. The temperature should be constant. So in the graph, where do you see a constant temperature? Okay, here, guys, look. This one, solid to liquid. This side, temperature is constant, okay, which is 100 Celsius, which is 100, and here is what? Here is going to be what? Is going to be our latent heat of fusion, okay, which is basically solid to liquid or liquid to solid. For Q, what are we going to do? Q is going to be this one, 8.37 minus 1.27. So 837 minus 1.27, and you should get 7.1 kilojoule. Change it to joule. It's going to be 7.1 times 10 to the power of 3 joule. Okay, now let's find latent heat. Latent heat is going to be 7.1, which is the heat, joule divided by mass, 15 times 10 to the power of minus 3 kilogram. And we get what? We get 4.73 times 10 to the power of 5 joule per kilogram. And that's it, okay? I'm going to erase this. We have C. C, it says what? The specific heat capacity of the solid, okay? The specific heat capacity of solid. Now, this is the solid here, okay? It is going to be what? Q is going to be 1.27 minus 0. So we already found our Q. This is going to be Q, which is equal to 1.27 times 10 to the power of 3 joule. Okay, what about the temperature? Okay, the temperature is going to be what? The temperature is going to be, look at here, this is the curve, so this is 100 and this is 0. Okay, so temperature is going to be 100 minus 0. To find the specific heat capacity, we'll use this equation. Cp is equal to Q divided by mass times delta T. Then we have Q, which is this one subtracted by 0. Then we have 1.27 times 10 to the power of 3 joule divided by mass, which is equal to 15 times 10 to the power of minus 3 times delta T is going to be what? 0. And you have 100 Celsius, so 100 Celsius minus 0. Subtract all of this, divide all of this, and you should get 846 joule per kilogram per Celsius. Okay, kilogram per Celsius. This is what this is C. We have D, it says the specific heat capacity of the vapor. Okay, the specific heat capacity of the vapor. So in here, what we are going to do, we are going to subtract this one because this is gas. Okay, so we need to find specific capacity of gas. Whenever, guys, it talks about latent heat of fusion, the temperature is going to be constant. When it talks about, in this graph, of course, I'm talking about this graph, this diagram, whenever it says vapor or the specific heat capacity of vapor or the specific heat capacity of solid, it's talking about specific heat capacity. For specific heat capacity, we need temperature. But for latent heat of vaporization and latent heat of fusion, we do not need the temperature. So look at this one here. This is gas, okay, which is from what? From 795 to 796 kilojoules. And this is from where to where? This is from, look, 300 to 400. Careful, okay? So basically, okay, I'll erase this. It's kind of annoying to always zoom in and zoom out. So for this one, Q is going to be what? Okay, Q is going to be 796 minus 795. And this is going to be what? This is going to be 1 kilojoule, which is going to be 1000 joules. Okay, now we need to find the specific heat capacity of gas or vapor. Specific heat capacity is equal to heat divided by mass times delta T. We have heat, which is equal to 1000 joule. We have mass, which is equal to 15 times 10 to the power of minus 3 times delta T is equal to what? It is equal to 400. Look at this. 400 subtracted by 300. Okay, 400 minus 300. Calculate this, and you should get 660.6 joule kilogram per Celsius. This is the specific heat capacity of the vapor. We have the last question, E. It says the latent heat of vaporization. Remember, I just gave you a note. I said, whenever it talks about latent heat, okay, the temperature should be constant. Where is the latent heat of vaporization, and which is related, of course, to gas and liquid, and the temperature is constant? Here, look at this one. Okay, this is the specific heat, the latent heat of vaporization. Okay, we can use this one to find the latent heat of vaporization. So this is going to be what? This is going to be, Q for this one is going to be 795 minus 15.8. And you get what? You get 779.2 kilojoules. And this is going to be what? This is going to be 779.2 times 10 to the power of 3. Basically change this one, joule. Okay, this is what? This is going to be our Q. Okay, now what about the temperature? The temperature is constant. Careful. Okay, we do not need the temperature. Now, latent heat of vaporization, Q is equal to mass times latent heat of vaporization. To find latent heat of vaporization, divide this by mass, divide this by mass, cancels. Latent heat of vaporization is equal to Q divided by mass. Q is equal to 779.2 times 10 to the power of 3 joule divided by 15 times 10 to the power of minus 3 kilogram. And then this is equal to what? This is equal to 5 0.2 times 10 to the power of 7 joule per kilogram. This is the latent heat of vaporization. Okay, we have question 5. Question 5, it says what? Question 5, how much energy must be added to a bowl of 125 popcorn kernels in order for them to reach a popping temperature of 170 Celsius? Assume that the initial energy, so the initial temperature, so this is initial and this is final, that specific capacity of popcorn is equal to 1650 joules per Celsius, and that each kernel has a mass of 0.105 grams. Okay, so first of all, we have T initial, which is equal to 21 Celsius. We have T final, which is equal to 175 Celsius. And then we have CP for the popcorn, which is equal to 1650 joule kilogram per Celsius. And then we have mass of the popcorn, which is equal to 0.105 gram. Change it to kilogram, it's going to be 0.105 times 10 to the power of minus 3 kilogram. Okay, these are all the givens we should be having, we should be using. Now, it needs what? How much energy? So we need to find Q. Q is equal to what? Q is equal to what? Now, Q is equal to what? Is equal to Cp mass delta T. Then Q is equal to what? Cp of the popcorn is equal to 1650 times a mass of the popcorn is equal to 0.105 times 10 to the power of minus 3 times delta T is going to be what? 175 final minus initial minus 21. Okay, now this is going to be equal to what? Q is going to be equal to 26.68 joules. Is that enough? No. Read the question again. It says 125, a bowl of 125 popcorns. Okay, popcorn kernels. Okay, so we should multiply this. This is only for one popcorn, so we should multiply this by 125. And Q is going to be what? It is going to be 3,335 joules. Okay, this is the heat of 125 popcorn kernels. Okay, now we have question 6, the last question. It says what? It says because of the pressure inside a popcorn kernel, water does not vaporize at 100 Celsius. Instead, it stays liquid until its temperature is about 175 Celsius, at which the point kernel ruptures and the superheated water turns into steam. Now, how much energy is needed to pop 95 grams of corn if 60% of a kernel mass consists of water? We're going to need this information careful. Assume that the latent heat of vaporization for water is at 175 Celsius is we're going to need this too, 0.9 times its value at 100 Celsius, and that the kernel have an initial temperature of 175 Celsius. Okay, now, first of all, we have mass of the corn, which is equal to 95 grams. Okay, and the percentage which the water, which most of the corn is water, is equal to 14%. Divide 14% by 100, you get 0.14. Okay, and what you're going to do, since not all of it is water, we're going to multiply this by 0.14, which is this one. Okay, 40%. Divide this by 100 and you get 0.14. Okay, you get 13.3 grams. Okay, change this to what? To kilogram. 13.3 times 10 to the power of minus 3 kilogram. Then initial temperature of the kernels is equal to, we don't need that information, but I'm going to write it, is equal to 175 Celsius. Then latent heat, let me write this here, latent heat for the popcorns is 0.9 times. So I'm going to write this here, is equal to 0.9 times the latent heat at 100 Celsius. Okay, I'm going to write 100 Celsius. Now, first of all, what is the latent heat of water at 100 Celsius? It is equal to 2.26 times 10 to the power of 6. So I have to multiply this by what? 0.9 times 2.26 times 10 to the power of 6. Okay, then I will get 2.034 times 10 to the power of 6 joule per kilogram. This is the latent heat at 175 Celsius. And we have what? We have, I think that's it, okay? Now, what should we do? We should basically find the heat required to, basically we're going to find how much energy is needed to pop the corns we have. So Q is going to be what? It is going to be mass of what? Of water. Okay, this is mass of water, careful. Okay, time is latent heat of vaporization. We found this one here. Okay, then Q is going to be equal to what? It is going to be equal to 13.3 times 10 to the power of minus 3 times 2.03 times 10 to the power of 6. Okay, now what should we get? Calculate all of this and you should get 2.7 times 10 to the power of 4 joules. Okay, this is the energy that we're going to need to pop the popcorns. Okay, now the kernels of popcorns. This is it. This is all the 6 questions for the section review. Please, if you have any questions, make sure to comment below. And if there is any mistake from the calculation, please feel free to notify me. I'll be really happy. Thank you so much and see you in the next video.